All right, so today's section is section 8.7, infinite geometric series. In other words, geometric series means to add up all the terms, right, that are geometric. So like a series means take all the terms, add them all up. A geometric series is a specific type of series that in which the terms are all getting added up, right? In section 8.6, we only added up a specific set of numbers, maybe like 16 terms, 20 terms, 7 terms, something like that. Okay, but today we're going to be kind of trying to add up all the terms. So notice one thing in this definition. So early, guys. How can you still be asleep? I haven't even bored you yet. Notice how in this sense right here, there is no S sub n, right? There's always supposed to be an S sub n, meaning like this is how many terms we're adding up, right? S sub 7 means we're adding 7 terms. S sub 10, we're adding 10 terms. Here it just says S, okay? Some books like to write S, and they'll put like an infinity here. Some books like to do that, meaning you're adding infinitely, you're adding forever, okay? But some books prefer not to. So I'm just going to leave it without, but just know that sometimes it is going to have an infinity down there if they want you to add infinitely, okay? In other words, you're going to keep adding forever. Well, that's an impossibility. I can't keep adding forever. I'll die before I can even get there, okay? Bless you. So if you even think about it, just counting to 1,000,000 takes a long time. Okay, it takes 1,000,000 seconds if you count it right? So so time will fly by pretty quickly. Okay, so we do have a formula how to add an infinite geometric series. It says that S is equal to A sub 1, so your first term divided by 1 minus your common ratio, right? 1 minus R. But the little requirement here says as long as your absolute value of R, so whatever R is, as long as the absolute value of it is less than 1, then you can use this formula. Okay, so notice under it, I said if your absolute value of R is less than 1, then we call it convergent. We say it converges. What it means is that it does have a sum. Okay, it adds up to something. But if the absolute value of R is greater than or equal to 1, then it diverges, okay, which means it does not add up to anything. It goes on to infinity, okay? It just keeps adding higher and higher and higher, never slows down, okay? And it just sums up to infinity. So we call it divergent, okay? So we'll say it diverges, okay? So sometimes if you try to find the sum of something and the absolute value of R is greater than 1, just say diverges, no sum, okay? It adds up to infinity. You can put infinity as well, that's fine. But if the absolute value of R is less than 1, then we say it converges and we'll find the solution for it, okay? How do we find the solution? We plug it into the formula, right? A sub 1 over 1 minus R, okay? Now I'm going to show you 4 different examples. They're all going to be from example 1 though. But I'm going to show you 4 different examples, and each one's a little different, so I'm going to try to show you like how you find your R values, etc. Okay, one of the most common geometric series are fractional ones. Okay, now the thing about fractional geometric series is that sometimes it's a little hard to figure out the R value. Okay, maybe you look at this and you're seeing like negative 7/5 plus 7/15 minus 7/45 plus 7/135. You notice, well, the top number never changes, right? So that's one thing I noticed, right? But then after that, I noticed that the denominators are changing, right? Like I can see the denominators changing here and there. So how can I figure out the R value? Now, when we did geometric sequences before, we talked about how you find your R value. Let me just kind of go back to it. Look down here towards the bottom. How do you find your common ratio? If you're given a bunch of terms, you're going to divide them, but backwards. You're going to go A2 divided by A1, A3 divided by A2, A4 divided by A3. So you're going right divided by left, right divided by left. And when you do that, the answer should match. Okay, if it is a geometric series or a sequence, it should match up, and that's going to be your R value. So remember, to find R, we divide. This is from section 8.5. We did that about 2 weeks ago, maybe 2.5 weeks ago. So I'm going to find my R value. I'm going to divide. So notice this is a sub 1, a sub 2, a sub 3, a sub 4. I'm going to divide these things and see if the R value is consistent. So let me start with A2 divided by A1. Okay, so 7/15 divided by negative 7/5. Well, that equals to negative 1/3. Okay. Now let me try that with the next one. So negative 7/45 divided by 7/15. Well, that's equal to negative 1/3. I'll do the last one here. A calculator is going to be useful. I'll recommend it to you guys. Minus 7/45. That equals to negative 1/3. So that means that R is equal to negative 1/3. Okay, so negative 1/35 divided by negative 7/45. I'll try to write that a little nicer right here. So negative 7/45. Okay, but that all equal to negative 1/3. So that means R is negative 1/3. What's a sub 1? Negative 7/5, right? They gave it to me. Because remember, I need to know a sub 1. I need to know R. Okay, so before I can use this formula, S equal to a sub 1 over 1 minus R, I need to check, is it true that the absolute value of R is less than 1? Well, my R value is negative 1/3. Is the absolute value of negative 1/3 less than 1? Well, what's the absolute value of negative 1/3? Remember, absolute values just make everything positive, right? So it's 1/3. Is 1/3 less than 1? It is. A third is less than 1, right? So this checks out. That's the only thing you got to double check when you're doing these problems. Okay, you're going to double check that your R value is less than 1. Okay, so now that I know that it's true, let me get my formula. I'm going to plug it in. A sub 1 is negative 7/5 divided by 1 minus R is negative 1/3. Okay, so I just plugged in my values into my formula. Again, a calculator will be useful. I'm going to do this by hand. So S is negative 7/5 divided by 1 plus 1/3. Well, negative 7/5 divided by 1 plus 1/3, that's 4/3. I think so. Let me see. It's 1 1/3, so 3, 4. Yeah, 4/3. And remember, we don't divide fractions, we multiply by the reciprocals. So S is equal to negative 7/5 times 3/4, right? Instead of times 4/3, it's times 3/4. And that equals to negative 21/20. And this is my sum. This is what it adds up to. Again, you can save yourself a lot of time by just plugging it into a calculator. That's totally fine. Nothing wrong with that. Okay? But the formula is not difficult. The numbers you plug in might look difficult, but with the calculator, I'll bring them out. It's not that bad. Okay? Just kind of combine everything together. Take your time with it, but let the calculator do most of your work. But just to kind of go over this, let me zoom out so I can show all of it at once. Okay, to do this problem, and these are probably like, I think these might be like the harder types, the ones that look like these. When you're doing these types of problems, they're going to give you a list of numbers that are added, right? Or sometimes you'll see addition and subtraction kind of oscillating back and forth. First thing you want to do is you want to figure out your R value. Okay, find R. So the way I found R is by dividing, right? A2 divided by A1, A3 divided by A2, A4 divided by A3. They all came out to a negative 1/3, which is good, because if they were different, that means it's not a geometric series. So then you can't even do this problem. Okay, so once we find our R value, negative 1/3, then I got to check it. I got to make sure that the absolute value of r is less than 1. If it is, then I can continue. If it's not, then I say diverges. There's no sum. There's no way I can add this up. Okay? So, but I have to test it. If it works, fine. I use the formula. If it fails, then I stop and I'm like, I'm done. Diverges. Okay? This one worked, right? The absolute value of r was less than 1 because negative 1/3, the absolute value, that's a third, which is less than 1, so that's fine. Okay? So then I use the formula. A sub 1 was negative 7/5 divided by 1 minus your r value, which was negative 1/3. Again, I did it by hand. You don't have to. But 1 minus a negative 1/3 becomes 1 plus 1/3. 1 plus a third is 4/3. And then I have a fraction divided by a fraction, so I'm going to multiply by the reciprocal. So negative 7/5 times 3/4 gives me a negative 21/20, and I'm done. That's it. This thing converges, okay? Sometimes they'll ask you, does it diverge or converge? You would say this one converges because it has an answer. It has an actual sum. I found it, negative 21/20, okay? If it failed the check, then you just say it diverges, okay? One of these will fail, I know that. Are we okay with this one? This one's the toughest ones, okay? These are the toughest ones. Now, this time they didn't put plus, plus, plus in the middle, but they are telling you to find the sums, okay? So they did give us these numbers. All right, so like I told you guys earlier, the first thing you're going to want to do is find your R value. Hold on, let me zoom back into normal here because I can see this is a little bit far out. So let's find R. Okay, remember this is A sub 1, A sub 2, A sub 3, A sub 4. You got to divide them all because if one of them doesn't match up, that means this is not a geometric series. Okay, this one will work, but I'm just letting you know. So A2, that's 27 divided by A sub 1. Well, that's equal to 27 over 81, which happens to be a third, a positive third. Now, let me get A sub 3 divided by A sub 2. That's 9 over 27. Well, that's also a third. Then 3 divided by 9. Well, that's also a third. So my R value is 1/3. So again, I'm going to use this formula, S equal to A sub 1 over 1 minus R. But in order to use it, I got to make sure that my R value in its absolute value form is less than 1. So the check step. Is it true that the absolute value of R is less than 1? Well, that means that the absolute value of 1/3 is less than 1. Is this true? Yeah, it's true. We just checked it. Granted, the last time was a negative 1/3, but in its absolute value form, it's still just a 1/3. This is true. So then that means I can use my formula. S is equal to A sub 1 is what? 81 over 1 minus, and R is 1/3. And now I'm just going to work this out by hand. Okay. So S is equal to 81 over 1 minus a third. That's 2/3. And I'm dividing a fraction, so I'm going to actually multiply by its reciprocal. So S is equal to 81 times 3 over 2. Now, I know that 81 cannot be divided by 2, but 81 can be multiplied by 3. So let's see, that's going to be 3, so 243 over 2. This is my sum. So again, I could say that this converges, right? I could say it converges. It has an actual sum. So it converges. So notice this one was a little bit easier. Why? It was pretty much the same like the other one. Well, it's because the other one had fractions, and when you're trying to do the division, it just looks ugly, right? The work just gets messy. Here, the numbers that I was dividing by, they were just normal whole numbers, right? So it doesn't look scary, okay? Sure, maybe I got fractions when I divided, but that's okay. But at least I wasn't dividing like 81 thirds divided by 27 thirds or something like that. right? It was just numbers. So same process we just did in part A. We're going to find our R first by division. We're going to divide A2 by A1, A3 by A2, A4 by A3. We're going to divide them, make sure that the R value comes out consistent all the time. If it doesn't, then that means you can't do the problem. So it should, because or else that'd be ridiculous for me to teach you stuff that you can't even do, right? So it should. All the problems should work out. You should be able to find an R value, okay? Now the question is, the R value that you found, does it work? Okay, that's why we got to do the check step. Sometimes it might, sometimes it might not. Okay, if it does check out, which ours did, then do the formula. We know our first term, it was given to us, 81. We know our R value, we figured that out. So you're going to plug it in and just work out the problem. Again, your calculator can do the work for you so that you don't have to worry about doing it by hand. Okay, little by little, we're going easier and easier. Okay, the first one we did was the toughest one. The second one, not so bad. Third one, I mean, can't really make it easier than this. Not only did I just give you the A sub 1 value, I also gave you R. So you don't even have to try to figure out any of the information. It's already given. Okay? We're still going to use the formula. S equals to A sub 1 over 1 minus R. And I still have to check, is it true that the absolute value of R is less than 1? Is it true that the absolute value of half is less than 1? Yeah, half is 0.5, 1 is 1, and 0.5 is less than 1. This is true. So then let me just plug it into the formula and solve. So here we go. S is equal to A sub 1 is 5 over 1 minus half. You'll notice I always put a parenthesis around the R value because sometimes R is negative, so I don't want to mess up and forget the negative sign. All right, 1 minus half, well, that's half. So, and 5 divided by half, that's 5 times 2 over 1, which is 10. So it adds up to 10. So we would say it converges, okay? We say it converges. So a lot easier than the previous one, right? And easier than the previous one before that. All you're doing is taking the information they gave us, literally the two most important parts, plugging them in and solving. But first, you got to check. Don't forget that check step. Because just so you know, you won't know that you did it wrong. Okay? You won't know that you did something wrong unless you do the check step. The sum will still work. You don't have to write this down, but look. Let's say A sub 1 is 2 and R is 4. Let's just pretend. Just look right here. Okay? Is it true that the absolute value of R is less than 1 in this case? Is it true that the absolute value of 4 is less than 1? No, 4 is not less than 1. But if I forget to check it and I just go straight to this, A sub 1 is 2 over 1 minus 4. That's 2 over negative 3. Guess what? I still got an answer. And I'm going to feel good about it. The problem is this is all wrong. Because I can't use the formula if the absolute value of R is bigger or equal to 1. I can't use it. I would have said right here, the absolute value of 4 less than 1, I'd say no, it's not. Okay? It's not. So I'm going to write no sum or diverges. That's what I would do. Okay? Because that's not true. The absolute value of 4 is not less than 1. That means don't do anything. You're done. Okay? Which is what's going to happen in example 4. Okay? So here we go. So example 4, we have the sum as I goes from 1 to infinity of negative 2.2 times 2.1 to the I minus 1. Remember, this is a geometric sequence equation, a sub n equal to a sub 1 times r to the n minus 1. I put it there for you guys so you can remember which parts are which. Okay, what's my r value according to this problem? What's my r value? I'll give you a hint. It starts with a 2. Yeah, it's a 2.1, not the 2.2. But it's 2.1. Okay? That means a sub 1 is negative 2.2. Okay? Now, before I start doing this formula right here, S equal to a sub 1 over 1 minus r, because notice I already have a1, I have r. I can just plug it in. But before I plug it in, I got to check. Is it true that the absolute value of r is less than 1? Well, my r value is 2.1. Is the absolute value of 2.1 less than 1? No. So then I'm just going to write no sum or divergent. Okay? Or if you want, you can even write infinity, because that's basically what's happening. It's going to keep adding and it's going to be an infinite sum. But I prefer saying like divergent is actually my favorite way of doing it, because in calculus we use these words a lot. Okay, convergent and divergent. But yeah. Okay, so that's it. That's all I have for you guys in terms of problems that you guys have to be able to do. Again, we went from hardest in terms of work to easiest, right? Here was the hardest problem. Why was it the hardest problem? Well, because it was in fraction form. And a lot of times the fraction forms, the work just gets a little bit more difficult because of the fact that they're fractions, right? So we found our R value. We made sure that the absolute value of R was less than 1, which it was. We plugged it in. We found our answer. I just put converges, right? I forgot to put the S there, but converges. And that was my sum, negative 21 over 20. Or they might just give you a sequence and say, hey, does this have a sum? So, okay, I found my R value by dividing. My R was 1/3. I checked my R value. It worked, right? The absolute value of 1/3 is less than 1, so great. I plugged it into my formula. I got 243 over 2, which does converge. It converges. So done, right? Less work than the previous one. This one was less work than the previous two. They gave you a sub 1. They gave you R. All you have to do is test your R value, which the absolute value of half is less than 1, so it works. Plug it into your formula, find the sum, okay? And we got it. It was a 10, so it converges, okay? I did show you in green like a really quick problem that was kind of like C, but notice my R value was not less than 1, so then I don't do anything. I just say there's no sum. It diverges, okay? Or the very last one, even though it looks like the most complicated one, it might work, by the way. You might see some problems like this where the R value is like a 1/4. Well, that's okay. 1/4, that's perfect. That works. But right here, a 2.1 was my R value. The absolute value of 2.1 is not less than 1. That means I can't do the work. So I'm just going to put no sum or that it diverges. Or if you want to put that it sums up to infinity. I know it sounds kind of contradictory that I say there's no sum or it sums up to infinity, but you guys got to understand infinity is not a number. Infinity is an idea. It's a large number. We don't know how big it is, but we know it's big. So if I ask you to give me an actual answer for infinity, you can't. It's a theoretical number. So that's why we say it has no sum, because infinity doesn't literally exist. It theoretically exists. It's just a large number. We don't know what it is. Okay, so let me go ahead and stop this. I'll give you guys your homework. I'm going to bring out the calculators for you guys right now.